Hello, in this video I'm going to be showing you how to find the x and y intercepts of an equation of the form y equals ax squared plus bx plus c. So let's say this over here is the y-axis and this over here is the x-axis. Let's call this equation over here, or this graph, y equals ax squared plus bx plus c. And let's say this point over here is 0. Okay, now since we have this arrangement, this line over here, this vertical line, is going to be x is equal to 0, and this horizontal line over here is going to be y is equal to 0. Now when we plug x is equal to 0 or y is equal to 0 in this equation over here, what we're going to end up with is these x and y intercepts, okay, for this graph. So we've got 3 over here for this particular graph. Now this coordinate over here is going to have the x value 0, and if we plug x is equal to 0 into this equation over here, or the graph, what we get is y is equal to c. So the y-intercept over here is going to be equal to c, okay, and this coordinate over here is 0, c. Now what we need to look for is these x-intercepts over here, okay, and if we make y is equal to 0 for this graph, we're going to get the equation ax squared plus bx plus c is equal to 0. Now getting the x values for these intercepts is going to be more tricky. We're going to need algebra that's a bit more complicated. So we know that to get the x coordinates of these intercepts over here, we have to make y is equal to 0, because this horizontal line over here is y is equal to 0. Now if we do this, we get ax squared plus bx plus c is equal to 0. If we subtract c from both sides of this equation, we get ax squared plus bx is equal to minus c. Now from here, if we divide all parts of this equation by a, we get x squared plus b over a times x is equal to minus c over a. Now from here, we're in a tricky situation. We need to isolate x, and the algebra is a bit complicated. So what we do is we transform x squared plus b over a times x into x plus b over 2a squared minus b over 2a squared, okay? And this is called completing the square. It's a bit of maths magic. Now we know that this up here is equal to x squared plus b over a times x, because when we expand this, we get x plus b over 2a times x plus b over 2a minus b squared over 4a squared. When we expand further, we get x squared plus 2 times b over 2a times x plus b squared over 4a squared minus b squared over 4a squared. These two over here cancel each other out, and the 2's over here cancel each other out. So what we are left with is x squared plus b over a times x. So this over here is equal to this up here. So moving on, we're at this interesting stage over here, and we transform this into x plus b over 2a squared minus b over 2a squared, and that's going to be equal to minus c over a. If we expand further, we get x plus b over 2a squared minus b squared over 4a squared, and we multiply minus c over a by 1, which is the same as 4a over 4a. From here, if we send this over here to the other side of the equation, or we subtract it from both sides, we add it to both sides of the equation, what we get is x plus b over 2a squared is equal to b squared over 4a squared minus 4ac over 4a squared. Now that these fractions over here have the same denominator, we can say x plus b over 2a squared is equal to b squared minus 4ac over 4a squared. Okay? And from here, we use the square root, okay, for both sides of the equation, and we get x plus b over 2a is equal to minus or plus the square root of b squared minus 4ac over 2a. Now, if we subtract b over 2a from both sides of the equation, what we end up with is x is equal to minus b over 2a plus or minus the square root of b squared minus 4ac over 2a. Now these fractions over here have the same denominator, so what we end up with is two values for x. When we isolate it, we get x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. Okay, and these values of x are at the x-intercept over here, where y is equal to 0. Now this formula over here is the famous quadratic equation, and it can be used to find the x-intercepts for equations or graphs of the form y equals ax squared plus bx plus c. So for this particular graph, when y is equal to 0, you're going to get the intercept 4x minus b plus the square root of b squared minus 4ac over 2a, and minus b minus the square root of b squared minus 4ac over 2a. Okay, so for these coordinates over here, y is going to be equal to 0, and you're also going to get these two intercepts. Okay, so for one of them, x is going to have this value, and for the other, x is going to have this value over here to the left. Now there is something to note about these types of graphs. You won't always get x-intercepts, okay? So I'll show you why. Let's move these variables. As you can see here, if c changes too much, this graph over here does not touch the x-axis, okay? Under these circumstances, there will be no solution for x when y is equal to 0. There are also other things to consider. When you change a, the parabola changes as well, okay? And if anything under this square root turns out to be negative, you don't have solutions, because we are dealing with real numbers and not complex numbers. So for any of these x values over here, if b squared minus 4ac is less than 0, you're not going to have solutions. If you'd like to play around with this same graph, you can do so by visiting the Desmos link below. So I've left a link to this graph underneath this video. For any support or questions, leave your comments below. I'll try to get back to you as soon as I can. For more maths videos, make sure you are subscribed. Thanks for watching and see you soon.